Hello wonderful person, this is Anton, and in today's video we're going to be talking about this unusual object that you see in front of you that actually used to be a star whose mass was eaten by the companion you see in the background. In other words, this is actually an example of what's known as stellar cannibalism, where a star eats another star, but in this case it didn't actually eat it completely, it turned it into a planet. Anyway, welcome to What the Math. So we are now located in the system known as J1433b, J1433b, and it's actually a system we discovered approximately a year and a half ago. But it's a system that has kind of been studied very quietly by several scientists because it's a very unusual system, and it's very unusual in the way it was created. Back in the days, this was actually a binary star system with two stars that were most likely very similar to our own sun. And this particular star that I'm pointing at that became a planet was probably about maybe a half or about 60% the mass of our sun. This one here that is currently a white dwarf was probably a little bit more massive. So we had two relatively big stars orbiting around one another. They were actually farther away from each other before, but then with time they actually kind of came closer and closer. So I'm going to show you how they were created, but before we do this, let's briefly talk about what we discovered here. So first of all, as you can kind of tell, they are extremely close to each other. And even though I keep calling them stars, this is technically now a brown dwarf. A brown dwarf is not really a planet, not really a star. It's an object that normally is a failed star, but in this particular system, it's very unusual because it used to be an actual star, and then it turned into a failed star. In other words, it reached a point where it lost so much of its mass that it basically became more of a planet than a star. It lost its ability to generate nuclear energy through nuclear fusion. And so now it is basically a brown dwarf. Now, this brown dwarf is very different from all of the other brown dwarfs we've discovered because its composition is probably entirely different. It's basically just all of the stellar matter that was left over from when it was a star. And a lot of the other matter that they used to have, specifically 90% of it, was actually eaten by its partner, that's right there, the little white dwarf that we have in the background. And basically, as it was eaten by the star, it then created a few very large explosions known as nova. Now, we may have actually witnessed these before, but when they did happen, we were still sort of in the infancy of astronomy, so we may have not really realized what we were looking at. So this wasn't a very recent event, this was actually probably thousands, if not millions of years ago. And what's left now is basically just this. Now, we don't really know anything else about this system, but we do know that, we know that they are basically really close to each other. We know that this object is about, in this particular case, it's about 57 masses of Jupiter, and it's just under the mass needed to start the nuclear reaction. If it was a few more Jupiters in mass, it would actually be an actual star. And we also know that unlike other brown dwarfs, here we can actually measure its atmospheric composition, and to some extent we can actually measure its temperature as well. So we've discovered that the difference between this side facing the star, and the opposite side is anywhere from 50 to 200 degrees Celsius. And we also discovered that on average this brown dwarf is extremely hot. It's actually something close to about, well, in this case it's about 17 degrees Celsius, but it might even be hotter than this. And although technically a gas giant orbiting close to a star is normally known as a hot Jupiter, in this particular case we don't really know what to even call this object, because it's not really a planet, even though it does behave like a planet now. And it's not really a brown dwarf because it was not created like a brown dwarf, but was made as an actual star. So for all we know, this might be a completely new type of an object that we discovered that just doesn't seem to have a classification yet. And it might even have completely different composition and completely different behavior to a typical brown dwarf and to a typical planet. Now let's go into Universe Sandbox, because I actually want to show you how and what made these objects and how they were created. So we're going to start Universe Sandbox. And so here, let's actually just take a sun and another sun. We're basically just going to use our own stars for this and place them in a binary orbit around one another. So here is that system that has relatively sun-like objects. We might actually change one to be a little bit more massive and then one maybe a little bit less massive, just to kind of simulate this a little bit better. Now, it's very possible that they were not actually that close to each other. They might have been actually farther away, and they may even have had like planets and asteroids orbiting around them. But obviously, as the time passed by, the bigger sun, the bigger star, reached a point where it just kind of started expanding, and it essentially turned into a larger and larger object. So here we can simulate this by doing the following. We're just going to increase its size. It reached a point where it turned into what's known as a red giant. And in its red giant stage, it's very likely started, and yeah, I should probably should have moved this farther away. And its red giant stage, it started to basically release a lot of its outer shell material. And here, this is where this material would have started to slow down its partner star. In other words, even though the mass is not really changing, the actual size of the star is changing, so it's expanding, it's becoming less dense. And so when the other smaller star starts touching the outer shell of this bigger star, it will basically start losing a bit of its velocity, because, you know, it's colliding with all of these particles that are in front of it, and so it's going to start slowing down. And at some point, the larger star is going to entirely lose its shell. So here we can basically do this by maybe doing the following. Let's see if this works. Boom. Maybe? No? Okay. Not exactly how I planned this, but basically it will then become a white dwarf. So I kind of cheated a little bit, but basically now I turn it into a white dwarf. And the smaller star have slowed down to the point where it's now very, very, very close to the white dwarf. And because it's so close to it, there's two things that are going to start happening. One of those things is that it's going to start feeling the effect of a very dense object orbiting really close to it. So let me just slow them down and make them orbit around one another a little bit closer together, just to kind of simulate this a little bit better. And so here, this larger star, which used to be the smaller star, is now going to start experiencing a lot of tidal effects. And these tidal effects will actually start basically sucking off the matter from the top of this, even before it reaches its red giant stage. And eventually, and maybe I'll actually move them a little bit closer to each other, and maybe now, I think it should be getting some of the mass from it. I should probably make it a little bit bigger just so we can experience this a little bit faster, but here we go. So eventually, this star, the one that's bigger in size but smaller in mass, is basically going to lose a lot of its mass. It's going to just kind of lose everything, essentially, lose about 90% of it. And as that happens, it will eventually turn so small and so insignificant in terms of mass that it's going to basically become what's known as a brown dwarf. But in this case, it's not really a brown dwarf because it wasn't born as a brown dwarf. As a matter of fact, it became brown dwarf through losing its mass. Now, this is what makes this system so unusual, so different, and so unique. And all of this mass collects on the white dwarf that is the companion of this brown dwarf. And eventually, as it basically circulates around, will reach the stage of a nuclear reaction and will then produce what's known as a nova. Now, that's kind of the essence of how this was created. And it's actually very, very interesting if we discover more of these systems, because in some sense, this is actually very rare, but it's also in some other sense, maybe a lot of other brown dwarfs were actually born in a similar manner as well. But for now, we can't really call this object a brown dwarf, the one in the distance there, because it's just not how we define them. It's really more of a failed star that turned into something similar to a brown dwarf. Well, anyway, that's all I wanted to talk about. This is the system known as J1433, and it's basically a system that you can easily find in Space Engine by typing the name in the search box right here. Thank you so much for watching, guys, and if you've enjoyed this video, don't forget to subscribe, share this video with someone who enjoys watching space videos and wants to learn more through video games, and come back tomorrow to learn something else. Let's escape the system and go back to Earth, at a distance of approximately 700 light years away. Space out, and as always, bye bye.